of the like terms. Now, the coefficients of the like terms, that's a fancy math term for the number in front of the variable. So if you didn't already know what coefficient meant, that's what it means. So we're going to do an adding polynomial, and actually when we write the polynomials, we're just going to talk together about what kind of polynomial it is, as a reminder of what we talked about before break. The first one we're going to look at is 2x cubed minus 4x to the fourth plus 2. This will be my first polynomial. And I'm going to put that in parentheses just to distinguish it from this second polynomial that we're going to add to it. But notice there's no number in front, so really we could drop off the parentheses, which we are going to do in the next step. But we're taking this polynomial, and we're going to add 2x squared plus 4x cubed minus 3x to the fourth. Now, looking at each one of these specifically, there's two ways that you can name it. The first way that you can name it is you could say that this is a degree what polynomial, this first one? Degree 4. Yes, because it's the highest. When I talk about degree of a polynomial, that just means what's the highest exponent, and that's the degree. So the highest exponent there is 4. So we have a degree 4 polynomial. How many terms does it have? 3. So we could also call this a trinomial. Meaning there's 3 terms. Quadratic is usually a trinomial because there's usually 3 terms in a quadratic. We could also call it a quartic because the highest degree is a 4. So we could call it a quartic function. You have like a linear, quadratic, cubic, quartic. This would be a quartic. In terms of linear, quadratic, cubic, and quartic, what do I have for the second polynomial? What's the highest exponent? Highest exponent is a 4, so yeah, that would make it another quartic. In terms of terms, do I have a monomial, binomial, trinomial? I have a trinomial here. Really, usually anything more than 3 terms, that's when they just call it a regular polynomial. They don't really name it something specific, but usually if it's a binomial or trinomial, it fits into certain patterns, so that's why they give it more specific names. Alright, so basically when we're just adding these two together, you just add and subtract like terms. So we look at the first term here, 2x cubed. Do I have another x cubed term in this whole shebang here? I don't have anything in this first one, but I do have a 4x cubed here. I can combine those by adding the numbers in front. So 2 plus 4 give me 6x cubed. You're just adding, subtracting like terms. Do I have a like term that would go with this negative 4x to the fourth? Yeah, this negative 3x to the fourth, right? So if I add those together, I get negative 7x to the fourth. Next term is 2. Do I have just a plain number? Nope, so that's just a 2. And then, what's the last thing that I have to add? The 2x squared. And there's no other 2x, or no other x squared term, so that just remains 2x squared. So all you're doing is adding and subtracting like terms. Usually they would write that in what we call standard form, which just means everything is in order. So we'd probably want to switch stuff around, and I might actually do that here. Because typically, especially later on when we're graphing these, we want them written with the highest term first, and then it goes down from there. Alright, subtracting polynomials. Let's go with 4x squared minus 2x, then we're going to subtract 9x cubed plus 2x squared plus 3x plus 4. So I just want to make sure we talk about all the different terms here. Alright, before we actually subtract these two polynomials, let's talk about what they would each be named, just as a refresher. This first one, what's my highest exponent? A 2. So the name I would give that would be a quadratic. Good. And how many terms do I have? 2, so we would call it a binomial, right? Because we've got 2 terms. All right, this last one here, what's my highest exponent? 3. So the name of it would be a starts with C. A cubic. Good. We have a cubic. And then in terms of the terms, I have how many terms? 4. And I told you anything above 3 we just call a regular polynomial. Just many terms. So we would call this a cubic polynomial, and we would call that a quadratic binomial, if you want to get specific there. That's not something that you have to know. That's not a standard. It's just kind of understood that we're going to be used to those terms, so I like to review them right now. All right, when you're subtracting, the only thing that is different from this type of problem up here when you're just adding is you have to be careful to subtract every single term here. So I usually suggest distributing that negative through and dropping the parentheses, because that eliminates the mistake of forgetting to subtract one of the numbers in here instead of just adding. So once you distribute the negative through, then you're just adding together your like terms. So let's actually do it so we're written in descending order. The highest degree term here that I see is what, Shay? What do you see as the highest degree? Oh, thank you. Yep, negative 9x cubed. Okay, let's go back to Shay. How many x squared terms do I have then? 2. So I have the 4x squared and the... Okay, if I add those together, yeah, I just get 2x squared. 4 minus 2 gives me 2x squared. The next term that would come in that order would be an x term. So let's go with Joe. How many x terms do you see there? 2. And if you add them together, what do you get? Yep, so that would be the next thing listed. And then the last number there, everybody should be negative 4, because we just have one single number listed there. Okay, not too bad, right? Stuff we've been doing pretty much all along, because it's just adding and subtracting like terms. Okay, go ahead and flip. Now, the little precursor that I tell my classes before we do this page of notes is that I'm going to show you 3 different ways to multiply polynomials. You only have to know and use one way. So I like to show these 3 different ways because depending on the student, they like usually one way better than another. So after we're done with this page, even though I expect you all to kind of follow along with me, you don't have to know each way. You have to just be able to multiply polynomials, so then these are 3 different ways that you could do it. Alright, to multiply polynomials, you need to basically distribute. Okay, so this is connecting to something that you already know how to do. You already know how to distribute and use the distributive property. That's basically what each one of these methods are doing. Each term in one polynomial has to go to each term in the other. And there's a couple different methods. We're going to, we're going to begin by multiplying 2x minus 3, which is what we would call a linear, because your highest exponent is a 1, a linear binomial. Good. We're going to multiply that by 4x squared minus 3x plus 1. And that I would call a quadratic, what? Trinomial, because we have 3 terms. Now, this first method that you can use is multiplying them vertically. So we're going to line these up. I usually put the longer polynomial first, so we're going to put 4x squared minus 3x plus 1. And then you list the smaller one underneath. So it makes it look like this type of multiplication problem that you've done before. But keep in mind that all you're doing is basically distributing each term in one to each term in the other. So usually if you're multiplying, like double-digit numbers, like multiplying 12 times 12, you take this number and then you multiply it by the 2 above it, write it down, and then same thing with the 1. We're going to be basically doing the same problem here, just with x's. So we're going to start with a negative 3. This negative 3 has to be multiplied by every term in the other polynomial. So negative 3 times 1 gives me negative 3, and more than one person can type up here. Negative 3 times negative 3x, everyone, is 9x, so that would be listed there. Then negative 3 times 4x squared, everybody, is negative 12x squared. Okay, so we have distributed negative 3 to every term in that first polynomial. Now we have to go through and distribute 2x to every term above it. So 2x times 1 gives me 2x. 2x times negative 3x gives me negative 6, what? X squared, good. And notice that your terms are lining up here. And then 2x times 4x squared gives me 8x cubed. And then what should we do now? What? Add, yeah. Notice that when you do that problem like you would do multiplying double-digit numbers or triple-digit numbers together, you just add the columns, and that basically adds your like terms. So we have 8x cubed minus 18x squared plus 11x minus 3. Okay, so multiplying polynomials is one way to combine them. You can line them up vertically and multiply them that way. Okay, same type of problem, just a different way to do it. So if you didn't like that example that we just did, the way it was formatted, this is another way that you can look at it. This is actually the one that I used mostly because probably my algebra teacher, that's the only way that he used in high school. But we're going to do a similar one, 4x squared minus 1. We're going to multiply that by 3x cubed minus 4x plus 5. Okay, let's name these just to practice. Anybody want to raise their hand and venture out to tell me what the name of that would be? Sydney? Close. Very close. It's not linear. It's quadratic. Good, because you have an x squared term. But yeah, it is a binomial. Quadratic binomial. What about this second one? Anybody want to try? Nick?
Cubic trinomial.
Good. Cubic trinomial. Cubic because the highest exponent is a 3, and there's 3 terms. Alright, this second method is just multiplying horizontally. Again, remember, basically all 3 of these methods are just distributing through. So we're going to take, and it's already set up horizontally, so we're just going to go with it the way it's written. We're going to take 4x squared, and you're going to distribute through to each term in that second polynomial. So 4x squared times 3x cubed gives me 12x to the 5th. Good. When you're multiplying two things with the same base, you add the exponent. So you should have 12x to the 5th. Then we multiply these second terms together. 4x squared minus 4x gives me negative. Good. Negative 16x cubed. Yeah. And then 4x squared times 5 gives me 20x squared. Okay. Then you can't forget about that negative 1, because every term in the one has to be distributed to every term in the other. So we're going to distribute the negative 1 through as well. And then just kind of tack it on to the end. So negative 1 times 3x cubed just gives me negative 3x cubed. Negative 1 times negative 4x gives me positive 4x. Negative 1 times 5 gives me negative 5. What do you think we do now? Add your like terms. Combine your like terms. So there's no other x to the 5th terms. So that stays 12x to the 5th. Then we have negative 16x cubed and negative 3. So we're going to combine those to get me negative 19. Anything else that we can combine? I don't see anything. So we only have one x squared term, one x term, we had to name this result, it would be a quintic, because it's raised to the 5th power, a quintic polynomial because there's more than 3 terms. Okay, this example 5, I didn't used to show this way, but then it started popping up on the MME that they were expecting you to know it, how to set it up this way. And plus, what I have found, if you're more of a visual learner and spatial thinker, that this is usually a quicker way for you to do it, because you're used to thinking of it in this way anyway. We're going to do a similar problem. 5x plus 1 times 3x squared minus 2x plus, 6. Again, we're doing the same thing. We're multiplying polynomials. This is just a different way to do it. We're basically going to be making a multiplication looking chart here with these. It doesn't matter which one you put across the top of this table that we're going to be making. I usually put the longer one on top, but it doesn't really matter. So 3x squared minus 2x plus 6. Just make sure there's some space between them. And then down the side, we're going to write the other one. So 5x and 1. And then basically make a little chart. Oh. Sorry. Now basically, to use this method to multiply, we're going to fill in each of these boxes like you would for a multiplication chart, if you remember those from elementary and middle school. Well, I don't know if you had a middle school, but big old chart, and you have a bunch of little boxes. Basically, if you match the column and the row to multiply them, what was in the box was the multiplication. So if you had 9, you had 4, then you would have 36 in the box. That's what we're doing here. So 3x squared times 5x. That's the result that we're going to put in this box here. 15x cubed. Good. 15x cubed. To fill in this box, you're going to multiply row and column. So negative 2x times 5x gives me negative 10x squared. Yep. And then 6 times 5x gives me 30x. Then to fill out the bottom row here, 3x squared times 1 gives me 3x squared. And we have negative 2x and 6. What's nice about this method is almost always the diagonals are your like terms. So I don't want you to leave your result, like when you're writing your answer, this should not be your answer, what I see right now on the screen. You should actually take the time to write out everything together. So 15x cubed would be your first term. Then you would add your like terms together here in this first diagonal to get negative 7x squared. Then add your next like terms to get 28x plus, what's the last thing? 6. Okay. Yeah. So 3 different ways to multiply. You just have to be able to multiply polynomials. I don't care which way you use. You just have to be able to do it. All right. 3 different ways for you to choose. I think today, before we start looking at the graphing preview, I want to do some practice. So grab a whiteboard. I'm working, right? I'll do that as your practice again. All right. Okay, I don't know if... Do we need markers? Yes, no? Okay. All right. We're going to skip around here a little bit. I'll write a little note here. Do numbers... Start with number 4. Or start with number 2. You're going to do 2, 4, 9... Oh, wait, you can't see 9. 10, 13, 16, and 18. Okay, so those are the 6 you're doing here. 2 adding and subtracting, and then 4 multiplication ones. And I don't care how you do the multiplication ones. When you're done, just show me. Just getting a good practice of putting them in descending order. And passing out progress reports. Anything that's highlighted as missing or important grades that you have to look at. It's not negative 8x. Good. Good. Very good. See? Not 4x squared. Good. Yep. Good. Should be negative 2x. Huh?
Like, okay, come over here. I'm about to have a heart attack. I don't want this right here. Something about to be way off here, and I want my uncle to crush. I don't want to get messed up here. Tell me anything weird.
That one?
Yeah.
But I'm missing your OR.
I just turned it in.
Oh, that's right.
Yeah.
Yep. So I'm not missing it. I just have grade yet.
Who's that?
Ooh. I'm not sure. I gotta. Which one is that?
Number 2.
Whoa. Oh, you're not multiplying number 2. You're subtracting.
I'm a dumb. He's the one that knocked me. I did.
Yeah.
So this could have been a little bit easier. You probably were right
Good.
there. You get a 3 point. You get the easy part of it. Why weren't you good?
I thought that would be silly. Look at your
I know. Way better than I thought it was.
Something happened there. You have 1 time terms. You're good. You're good. Good. Alright. Of course. Alright. You're good.
Did you say I have to do tomorrow?
Do tomorrow. Friday? Friday.
Oh, so we're gonna just do it this week. I was getting something easier next week.
Oh, yeah. Yeah.
You want
I thought you were asking if it was okay if I honestly asked you.
No, no. I'm doing it for 5 minutes.
Yeah, I gotcha. Yeah,
Four
say
says
that. Yeah.
For what?
You're good?
4 says 2x cubed minus 6x plus 4x close
Good.
parentheses plus open parentheses 4x minus 4 minus 2x cubed plus 4x squared plus 1.
On your progress reports, the column that says grade is the one that you want to look at, not the one that says score.
I said
The column that says grade.
I didn't get the
Good.
report that said cubed.
PowerSchool does something funny with that score
No,
column.
no, it goes cubed is
The abbreviation.
it's just raised to the 4th. Raised to the 4th. I think I did that right. So happy right now. Good job, idiot.
No homework tonight.
Aaron's is tonight.
Oh, really?
Dude,
Plus.
this is almost technically the rest of the week.
That just means
No,
I'm
very good.
missing.
Good
Oh,
job,
did
good
you
job.
not finish your test? You might want to come in and check because I didn't grade it yet. So once we get it.
Where's the next what I have to do the take the SIT when I got to like one SIT before.
Yeah, I don't know why.
Does
I will
grade
double.
count?
It shouldn't count.
Oh.
Yeah, I don't know why. Yeah. If it does that closer to the end of the semester, I can't figure out how to make it not count for you because I've marked everything as not counting. But I can physically change that grade to what you're getting for the Q2. So
Okay.
for you, just look at the Q2.
Okay, thanks.
Yep. Pretty sure I am. I don't. It's not for points. It's just me tracking like what you do. Yeah. Okay, then you'll need to come in and get that from me at some point. Because I don't know if I have any copies laying around, but I can print one off for you.